Thank you, everyone, for joining us today at the Defense One Tech Summit. I'm here with Lieutenant Colonel Daniel Bartos from the Cloud Computing Program Office at DISA. My name is Mark Johnson. I'm the Vice President of Federal Cloud at Oracle. I also was a naval aviator for 21 years, flying aircraft in combat and as a test pilot. I co-founded a small business afterwards and now work for Oracle in trying to contribute back solutions to the Department of Defense. Lieutenant Colonel Bartos?
Yeah, thanks, Mark. So Lieutenant Colonel Dan Bartos, I am the Marine Corps User Engagement Representative within the Cloud Computing Program Office. Before I go into kind of my background, I wanted to give a quick brief overview of the CCPO. We are a standalone center within DISA, and we do all things cloud. Our mission is to transform cloud to enable the warfighter. Working to bring cloud to our mission partners, making it faster, more secure, leverage to make data transmission more survivable out of the tactical edge. We prioritize initiatives that solve enterprise-wide cloud challenges and are consistent and support the DoD's digital modernization strategy. Real quickly about myself, I'm actually a career logistics officer who relatively recently came into the IT field. I've participated in multiple combat deployments to both Iraq and Afghanistan, as well as a number of different exercises and training events across the globe. Across my experiences, I've noticed that our deployed forces oftentimes deployed with very heavy manpower footprint. And when I look back at these experiences, I found that a lot of the cases, some of this redundancy and large manpower footprint was manning that was meant to manually input or monitor data being generated at the tactical edge on the battlefield. Additionally, another thing that I observed in my experience is that a lot of environmental conditions can be just as problematic to operations out at the edge, just as the enemy, especially with reference to data connectivity and transport out at the edge. So that's why I'm really excited to participate in this discussion today.
Lieutenant Colonel Bartos, you mentioned the people that are out there at the edge working on the data, trying to massage it. What are some of those challenges that they're trying to overcome in getting the data to the operators today? First,
we encounter very difficult conditions. The one that comes to mind first and foremost is your disconnected, low bandwidth, or inside the DoD, what we refer to as DDIL, denied, degraded, intermittent, or limited. Again, as I alluded to earlier, these conditions can be created not just by the adversary, but also by environmental conditions. So there's a lot of uncertainty in when you'll encounter these. And so as a result, we've built a lot of overhead to fight through some of these challenges through brute force, rather than leveraging technology out at the edge to work through them. Additionally, a lot of our systems out there just really aren't interoperable. Where data that's being generated and processed in one system needs to be read and processed by another system, but the two systems don't necessarily talk. And that's where a lot of that heavy manpower footprint comes in, is to be able to create that bridge between the two systems and their data collection and processing, and then ultimately the decision making. Real closely tied to the system interoperability piece is the lack of a cross-domain solution. The ability to move data across domains from unclassified to classified levels. So very often you'll find that data is being generated and processed in one classification level, yet it needs to be read and processed in a different higher or lower classification level. But the lack of an enterprise or even a viable tactical cross-domain solution makes this very, very difficult. Again, often relying on human intervention to move data across those information security domains. And it's a very, very difficult, time-consuming process. Additionally, what I found is that a lot of our legacy or existing applications need a significant amount of refactoring or overhaul to be able to function at the tactical edge, especially in those disconnected or degraded conditions. A lot of the applications today are built very similar to how we operate with our cell phones, where you have ubiquitous connectivity. Well, it's not always that's not always the case at the tactical edge. So there's going to have to be a very heavy engineering overhaul and refactoring of our applications to be relevant and functional out at the edge.
Yeah, that was certainly something I saw out there in the connection between the ground and the air, for instance, in trying to get data moved back and forth. And some very clever solutions developed by people in the field to solve some of those problems that then needed to be brought back to the enterprise, right? And legacy apps couldn't do what they needed to do, so they were able to build something new and use that at the edge to solve the problem that they had. So Colonel Bartos, how do you get data that's in the enterprise or the theater systems out there to the operators? And what do you decide to send to them when they know that they have these low bandwidth and disconnected networks?
Well, Mark, I think the first thing I'll tell you is I don't have the answer for the DoD. But what I can tell you is the more we experiment and explore the capabilities, the faster and sooner we'll come to the right answer. And to me, that is the critical piece to be able to get to understand how we're going to move data from the enterprise down to the operator, and then vice versa, back from the operator back up to the enterprise. Mm-hmm. If we don't get out and experiment, explore, especially with some of the tactical level operators, I don't know that we'll ever really understand what the right path is. Additionally, working through those seamless interfaces between systems, if we don't get out and explore and experiment and honestly fail in some cases, we aren't going to understand what actually does work. Additionally, there's so much data that's out there. It's impossible for us to manually sift through it all. I think there's an opportunity to leverage machine learning to identify what's the right data to move back and forth between the enterprise and the edge. This is one of the things. Rather than today, it's manual intervention to identify this needs to go down, this needs to come up. But over time, we can take advantage of some of the advanced technologies that come with machine learning, where at machine speed we have the ability to identify these data points of interest, and eventually over time build models around those machine learning capabilities. And then obviously being part of the Cloud Computing Program Office, I have to speak about the ability of a cloud to be able to support and enable that interface and transfer of data between the enterprise and the edge and vice versa. Cloud provides much more than just platforms and infrastructure for data and applications. It also provides global transport. The cloud service providers that we utilize today, they are international corporations, and therefore they have a global footprint. And this is something that the DoD can absolutely take advantage of to enable its operations around the globe. So coupled with that ability to move data back and forth is the ability to inherently utilize the native capabilities resident in the commercial cloud.
Yeah, I absolutely agree. And that's one of the things we're working on, which is trying to make that interface between the cloud technologies and the forward deployed technologies seamless, to be able to do, for instance, detach a piece of the cloud and take it with you as you're deployed. And you might be disconnected for a while, but you're familiar with the interfaces. It collects the information. It uses the same models. And then once it's connected back into the overall global network, it's able to synchronize the information that it has. That's what I see as seamless data transfer, what we're really trying to do, and make sure, of course, that it's secure all the way, right? So it's secure when it's on the device that's at the forward edge. It's secure in transit back and forth, whether that's a wireless transit or plugged into some sort of system, such that the operators know that their information, even if it's unclassified, can be sensitive, right? And then there's certainly the higher level classifications that you talked about a little bit earlier. How do you get this valuable data that's collected at the edge on some of these systems back to the enterprise? You mentioned the value of the cloud and the global connectivity. How do you feed that global connectivity in that cloud so that everyone can take advantage of what is learned out at the edge?
So there's a couple things that you can do. Number one, I believe there are still advantages we can look towards with our networks. Technologies are developing associated with mesh networks at the local level. The cloud service providers are entering into partnerships with satellite communications providers. There are more and more transmission paths available that make our networks a little bit more survivable and redundant to be able to enable some of that data transfer back from the edge to the enterprise. Additionally, this comes with that refactoring I spoke about earlier. we need to identify what data needs to go back up to the enterprise. Do we really need to take up all of the bandwidth and resource utilization in our network to push raw data back up to the enterprise, or can we process it out at the edge and only send what's absolutely needed back to the enterprise and leave those network resources open for other traffic and other needs that are out there at the edge?
Yeah, I absolutely 100% agree with that. I think it's about having not just computers at the edge or a handheld device, but it's something that is network aware even when it's not plugged in, right? It has machine learning on it that understands what it's collecting, what it needs to collect, what is important to the enterprise, to the theater, to other operators within the theater, right? So if something is going up to the air and back to the ground, for instance, like we talked about, the different views that we have of the battle space. I think that those machine learning built into the system is critical to that. And that's one of the things we're working on to try to bring to the DoD to make it simpler to implement things. It's built in. It's not machine learning and AI isn't something separately we think of and we try to build something, but it's just part of all of our systems, right? We make all our systems smarter all the time. But of course, the question is, who builds those models?
I'll go back to one of my previous questions. I'm not certain what the right answer is. I think it is a balance of between operators and data scientists out at the edge, and then data scientists who are operating out at the enterprise. Obviously, by utilizing the enterprise, you're able to take advantage of the massive amount of resources you have kind of centrally managed. And the power that lies there. But as I spoke to earlier, if we know we're going to run into some of these isolated, disconnected conditions, you need to empower and enable the edge to be able to solve some of their own problems. So out at the edge, you need to have some of those data scientists, the humans able to understand and build, adapt to the models out at the edge as well. And not just humans alone, humans enabled with local machine learning capabilities to go after some of those problems. Where that balance lies, I don't know, but that goes back to the idea of experimentation and exploration. That's the only way we're going to kind of find the right balance of what works at the edge and what works out at the enterprise. I don't know that we know that yet, but we're not going to find out until we actually get out there and get our hands dirty with understanding what works where and how.
Yeah, as a test pilot, I am completely sympathetic to the point of view that the operators must be involved in the system, right? If you just have data scientists or engineers, as smart as they are, they're not out there at that edge, right? And they don't exactly, as much as we can talk about it, they don't exactly live it and see it the way the operator does. But the operator doesn't know how to build those models, right? So it's definitely a give and take. And I think it's important that we have that feedback. We have, like you were talking about, the experimentation, the trial and error, the change, and use systems that are very flexible and adaptable so that they can be quickly updated. How do you secure this entire data process from moving it from the enterprise to the edge and then securing it on the devices?
So great question. So when you talk about security of data that's on the devices locally out at the edge, fortunately, this is one of the things the DoD does well. We're good at physical security. However, cybersecurity, now data in transit, it becomes a little bit more difficult. As a department, there's signs we're definitely moving in the right direction. A lot of development at the with zero trust principles, and those are some of those new models and ways we're moving that are going to apply really well out at the edge. Additionally, some of the principles that we're applying in some of the DevSecOps models are being applied into development out at the edge. So the same way you develop apps at the enterprise level will be the same way you develop apps and models out at the edge using the same DevSecOps principles. Inside the CCPO, one of the areas we're pushing forward with is infrastructure as code, where we're trying to build baseline code that users can apply out at the tactical edge that already comes with an accredited baseline. And therefore, you know that the development you do on top of it is going to be secure based on the accreditation of that baseline code that you're developing on. And then additionally, out at the edge, obviously always present of concern is signature management, not just from an electromagnetic perspective, but also from a cyber signature perspective just as well.
Yeah, I think that's super important when you're talking about iterative development, Gen 1, Gen 2, to start with a system that's secure from the inside, right? It starts out and its very core is a zero trust kind of architecture. And that's what we're trying to also build as we build the cloud, as we build detached devices, as we make all of it work together. It's always thought for security first, and then developing the functionality that you need on top of it, making it seamless though, right? Not slowing things down. It's important to say that, operations are not secondary to security. Security enables operations, right? That's the way it should be. And I've seen some people say, oh, well, we can't do that because of security. And it's like, no, we need to figure out how to do it securely, because the operations is what's important, right? Getting the mission done. Again, this is the pilot of me coming out and thinking about how do we apply these things so that we can support the warfighters.
Hey, Mark, I wanted to ask you real quickly, what does the industry have to offer to address some of the problems that we're seeing with data out at the tactical edge? How can industry help facilitate some of the exploration, experimentation I spoke about earlier?
We in industry are really excited about helping out. There's so many people like myself that have come out of the military and are looking for ways to contribute back. I'm pleased to see that now we've changed the way we do some acquisition. We're trying to speed up a bit of the process. We have the other transaction authorities now. We have cooperative research and development agreements. Those are critical to doing this experimentation that we talked about, to providing the new resources and looking at it new ways, to bringing in different data scientists. It shouldn't be just DoD's responsibility to hire everybody that they need here. They should be able to reach into industry and all kinds of different industries, by the way, not just the defense and industrial base. But it's important to define the requirements really well. I think that's one of the most important things that's kind of overlooked sometimes, is that when DoD is trying to say, this is what it is we need, it's kind of difficult sometimes to really kind of put your arms around that as you're experimenting with it. And so sometimes I think they look to just do CRADAs or something to try to work through that rather than try to define it. But if you can, it leaves the entire industry of innovation to bring solutions. And I think that's incredibly valuable. No one agency or company has all the answers, right? And so if you can put it out there and let the whole world contribute back, I think it's super important. Open source, really super important, really valuable. But how do you use it? There's lots of great companies that are using it very innovatively and can bring that back to DoD. We talk about DevSecOps being a very quick way to do development and add features and functionality, constantly rolling out updates. I think ActSecOps, acquisition, but always with security at the middle and operations being ultimately the focus. That's what I think DoD can do to have industry help as much as possible. We're ready to lean in. Tell us what you need and we'll contribute.
Those are some really great ideas. I like the idea of the cooperative research agreements. I think those are the types of things that we need to facilitate some of that experimentation, exploration without having to be dragged down by the standard contracting process, which often becomes long, drawn out, and often perceived as burdensome. So I think some of those creative ideas to get after some of those resources that industry has to offer has a lot of potential for the Department of Defense.
I'd like to thank everybody for joining us today, and especially Lieutenant Colonel Bartos for his insights and the ability to share them with us today. Thank you, Colonel Bartos.
Hey, thanks, Mark. Appreciate you having me here today and being able to chat and exchange information. I also want to thank the Defense One team for having me as well. So thank you all and have a great day.
And back to the Defense One Tech Summit editorial team.